Gonna wait for the dog to shut up. That's April. I don't think you're gonna meet her by the time you're here, but that's April. She's awesome. She is a threat to the human race. That's the heater. Let's pause for heater. It'll be about 5 minutes. I'm losing light. Okay. Hey, honey, it's your dad, Jake. Don't like. Let's just begin. Right? Okay. First of all, I want to show you a couple things. I got this cool mug that I love. It's like I got a new phone, so I don't. There you go. Oh my god. Well, it's a dog looking up at the stars. I think it's really well made. I love the color scheme. You know, I have a dog. His name is Buddy. He's a golden retriever, and he will every night go out on the deck and look at the stars just like this. And I love that. It's my favorite thing that he does. And I think a lot of Goldens actually do it. He probably won't be around by the time you're here, but I hope he is, and I hope you are too. Like I hope you're here sooner rather than later is what I mean. Yeah, so in the book 2001: A Space Odyssey by Arthur C. Clarke, the main character in the beginning, the first third of the book is called Moonwatcher. That's what they call him, and I love that name for him. And he's basically the most astute, the most observant, and connection making monkey among all the idiot monkeys. All the monkeys are stupid relative to the time, the genius of the time. But Moonwatcher can make some connections here and there. He doesn't quite understand what his mind is doing, but the people with the species behind the monolith know that he might be the brightest one there. We'll talk in further episodes about what it means to be smart, how you define intelligence, how I define it, things like that. Okay? But we're here to talk about something really exciting today. It's called the James Webb Space Telescope. I got this hoodie on that my friend Rahul Chatterjee got me. I'm not quite sure if this is the Pillars of Creation, but the Pillars of Creation, this might be a section from it, but the Pillars of Creation is a photo, probably the best, the most famous photo that the Hubble telescope took. The Hubble telescope was named after Edwin Hubble. I'm not sure how I'm going to edit this down. And I fact check this every time because I don't quite believe it, but they had said that in the original image of the Pillars of Creation, these small spires coming off the top, to get a sense of what you're looking at there, that is bigger than the entire solar system. So our entire solar system that you're living on, that I'm living on right now, where I'm making this video, it is smaller than that section. So then how big is the whole thing? And if you see the whole image of the Pillars of Creation, it's huge. So it's a star nursery. It's where stars are born. So yeah, the Hubble telescope was named after him, and it's taken some of the best images. I don't know why I'm losing my energy here. Gotta imagine I'm talking to you, right? Okay, let's keep going. The issue is that the images that are sent back were out of focus. At the time, late night comedians and the news and everybody was making fun of the project. So it's easy to make fun of those projects, but they made fun of it because this very expensive project failed, and like the images that it came back from the edges of the universe were not that good. But then in subsequent missions, they went up to the Hubble telescope and they fixed it, and what they discovered was that the lens was off by 1/50th the width of a human hair. That's a good place to start with this one. So the James Webb is what we're going to be discussing here. The James Webb is going to be sent up in 2 days. I think today's the 22nd, I think, of December 2021. So it'll be sent up, I think, Christmas Eve. And this video is out of order in the way I want to do things on this Dear Daughter channel, but whatever. Life is out of order too, right? So I think it's an appropriate place to start. Why not? So the James Webb telescope, I should have like a dry erase board, I'm realizing, but it's a huge telescope about the size of the heater went off. Let's continue after the heater. See you in 5. Now where do we leave off? Yeah, I should get out something to write with. Next time I'll have like a dry erase board or something so we can do this neatly. You can ignore this. Okay. So light will come like this, right? Can you see that? Yeah. And this is a concave mirror. This is called the primary mirror. Light will hit this and bounce because it's concave, that shape. It'll bounce into this. And this is a convex mirror. I believe that's convex mirror. This is the secondary mirror. Secondary mirror, okay? This is the primary mirror. Primary mirror. And then there's a third mirror in here that it goes to right behind. This is called a tertiary mirror. Tertiary. I believe it's called tertiary mirror. Tertiary means three. That's I'm not sure if it's Greek or Latin, but that's like the etymology of it, so you know what that means. Tertiary. And on this are 18, I think 18 hexagonal mirrors. A hexagon is six shaped. 1, 2, 3, 4, 5, 6. Also, it's 6 points. Okay? You learn that in geometry. Ugh, I gotta not figure out how to focus this. You see any of that? Okay. So, this is called a 3-mirror. I'm not sure how to pronounce this. Anastigmat. Anastigmat. And why, I'm going to get my face out of it. And why it's called that. Wait, is this recording this backwards or forwards? Let's figure that out later too. Let's look at the root word. Okay, your word of the day. Every video is going to begin with the word of the day. This one is going to be stigma. So I actually have something called astigmatism. I think I have 2 astigmatisms. And that word, stigma, and then ism is like an American thing. Means without. Stigma means point. So what it's saying is that the lens and the back of my eye, how light and how focus works is that it has to come to a point. That's how you see clarity. If it's off of that point, if the surface receiving the light and the point are off like this, you get a blurry image because that image is coming in and there's an axis point. I believe it's called an axis point, and then it goes out. It goes away. You're receiving, membrane or lens or hexagonal mirror has to be on that point. Then you'll see the image in focus. So when they said that the Hubble was off by I think 1/50th the width of a human hair, that's the issue there, which is pretty astounding. How small that could be off, but how the images were blurry. Okay, so I have astigmatism. This is called anastigmat, a 3-mirror anastigmat. That means without astigmatism. I believe that's the etymology of that. An means without astigmatism. I think I might have that right. Astigmatism means without stigma. Stigma means point, by the way. I'm not sure if I said that already. This video is going so poorly. Now I know what to do for next time. I'm like getting a transcript ready or something. And there's a word stigmata, which in Christian religion means the points on Jesus's hands when he got nailed to the cross. Oh my God. I'm not sure if stigma and stigmata are the same. I know stigmata is a plural form of stigma or stigmas, but I'm not sure if that also means the same point as the ones on Jesus's hand. Like a social stigma means something that you might have done wrong. There's a stigma around something. I think the origin of that too was that people got branded. So there's a stigma on them when they did something wrong, like adulterer, murderer, thief, whatever. So there's a point on them. Anyway, you see what we're trying to connect here? Astigmatism in the eyes. 3-mirror anastigmat is on this James Webb. That's because there's a primary, a secondary, and then a tertiary, which means 3. So we're going to keep connecting language and stuff as we learn, okay? Because there's a lot of language to be learned and where things come from. You don't really have to memorize anything, but it's kind of good to know the origins of things and why we speak a certain way. It's funny that the word will be stigma or astigmatism or anything related to that, because the official word of the day that I wanted to start the whole series on was myopic, which is also an eye condition, myopia. And it's about being nearsighted. We'll talk about that in like the proper first episode, but it's funny that they're both related to the eyes. Let's make this connection. Why is it related to the eyes? Something optical, which is what Newton studied in his Annus Mirabilis, 1666 in England. Because let's define what a telescope is. What the hell is a telescope? Other than this, it's an eye to see things with, to see things with. It's a bucket. That's another way to think of it. It's a bucket. It's a bucket that collects light. So you can see me because there's light coming off of me. And some people might say I'm brown. I think it's more of a rich mahogany. But the FBI described me as olive skin. I remember after 9/11, they talked about Osama bin Laden being olive skin, and my family was laughing, going, "I think we're olive skin." In Hollywood, they go, "Can you play the brown guy?" Brown. I've never thought of myself as brown. I have a argument against why we should stop calling black people black and white people white and all this. It's so unscientific and stupid the way people talk about each other. And we'll talk about race and all that stuff, but it's so stupid. Anyway, if you know, like, even basic science. Back to the thing. Now I realize there's going to be a lot of tangents when I talk, because there always is. Interdisciplinary knowledge, that's the key here, hon, all right? Interdisciplinary knowledge means knowledge across other various disciplines through which hopefully we can run a through line and kind of figure out how things are connected. That's how my mind works, and I'm not going to say that's how I hope your mind works, but that's what the whole point of this is to make a connection across different disciplines. So it's a bucket, it's an eye. That's what your eye is. Your eye is a bucket collecting light. That's why when it's nighttime out, your pupils will actually dilate. Hard to see my pupils because my eyes are really dark, but when it's dark out, your pupils will dilate. They're dilating to open up that bucket to collect more light. Another kind of evolutionary thing is you can tell sometimes if somebody likes you based on if their pupils dilate. You can't really tell with mine because it just looks like black on black sort of thing. But it also led to some weird things where if I thought a girl liked me, I would be like, and then making a face trying to figure out their pupils. So I was like, "Hey, I'm Jake." They're like, "Hi, I'm this." And I'm like, "Really?" And they're like, "Why are you looking at me like that, you creep?" So single. Okay, what are we? It's a bucket. So when you talk about a telescope, you're talking about a bucket. If you're looking to buy a telescope, which I'm in the market for, I'm shocked that I don't have one. It was actually a big thing when I was a kid regarding my parents, and like I was 9 years old and I asked for a telescope, but we couldn't afford it. I remember the argument. I should have got one back then, but whatever. People get things in life, people don't. I'll do a video about the Keck Observatory on top of Mauna Kea in Hawaii. It was a beautiful trip and a beautiful experience that I had with my cousin Bob. Yes, that's his real name. I laugh every time because I don't think it's his real name, Bob. It sounds like an Indian guy trying to fit into America. Just pick the most. I'm Bob. Yeah, of course you are. But that is his real name. Really cool guy. We'll have an interview with him later. Really interesting guy, very smart. A telescope is a bucket. You collect light with it. And that's what this James Webb telescope is. I was going to go into like the poetic stuff later, but let's go into it now then. Let's think about Galileo. At the time, people thought and we'll talk about this a lot later. At the time, people thought life and the Earth was geocentric. Geocentric means that we are geographically, geo, in the middle of the whole universe, not just the solar system, but everything revolves around us. That is man in his ego, as I believe Carl Sagan put it, man in his ego. You think everything revolves around you. I believe it was Copernicus who then wrote a book mathematically explaining how, and the way Sagan wrote it is, or explained it in a lecture, only publish this and read this after I'm dead. And if you're reading it, it's for mathematicians only. I'm not saying it's the truth, it's for mathematicians. If you're a mathematician, you can read it, but it's only math. And why are they like afraid to explain that this may be the truth? Is because the church was coming after them at the time. And, squashing science for going against it. And so anytime you spoke up against the church or against the belief that we may be the center of everything, not only was there a stigma around you, but you're persecuted. I believe that's what happened to Galileo, as the church showed him devices of torture and then put him under house arrest. I mean, that's one of the greatest minds of all time in our species, in the human race. But let's think about what Galileo saw. We'll get to all that stuff later. I'm very big on arguing those points and bringing our species out of its adolescence and into maturity. So we will speak about that later. Let's start with the basics here. Galileo made a homemade telescope, and from that telescope he would look out at the night sky. He would see things like Jupiter, and he noticed that Jupiter had moons around it. Okay, so he saw Jupiter. He goes, "Wait, that's not a star. That's a planet." And around that planet, there are other planets. Oh, wait, maybe those are moons, just like our moon. And I believe he also was the first one to see the Great Red Storm, the Big Red Spot, whatever it's called. I forget what it's called now. It's like a 500-year-old, as far as we can tell, storm that's larger than Earth. It's a storm that's raging on Jupiter that is larger than the entire planet of Earth. I should research how many Earths can fit into it. I think it's a few Earths or something. And it's been raging for more than 500 years. That's because that's the first time that we ever saw it. So, you want to tell how somebody has a Boston accent? There's an old test you can do. People think that New Englanders drop their R's. It's not just that. They drop their R's and then they add an R to a word that doesn't have an R, that doesn't require one. So the old test is Law and Order. There's a show, and there's also Law and Order, and they would say Law and Order. So they took the R out of the order, put it on the Law and Order. But I digress. Where are we? A telescope. Yeah, so let's think about Galileo here. He's observing Jupiter, okay? But we have this big, beautiful, thick, gorgeous, luscious atmosphere that I love. I love our atmosphere. It's like the best thing ever. It's the best thing on Earth. Because, and that is not only, protecting us from gamma radiation, X-ray, UV light, all that stuff. That's not only helping water parts of the Earth and keep the climate right. It's literally almost like a lung system around the Earth, moving air around and keeping things satisfied and in order. Of course, humans are the ones who try their hardest, not humans, but corporations and greed that try their hardest to ruin it for short-term gain. We'll go into all that deep stuff later about how I think the greatest enemy is short-termism. I've been saying this for over a decade now, and I'm finally being proven right. But we have our big, beautiful atmosphere. The downside of that is this: anything that you want to see in outer space has to go through the atmosphere. So not only, I'm not talking through literal clouds, which can actually, block it, but there's so many chemicals in our atmosphere, so many elements that are blocking the clarity of what you could see if you just go into outer space. What I'm trying to say here is this: Galileo wants to look at the universe, and the universe is infinite. He wants to look at the infinite. And I wish I could show you the scale, but whatever the infinite is, you are nothing on it on this little planet, surrounded by a tiny atmosphere that's really great for us. So he's sitting there in Italy trying to look, and he has to go through the atmosphere. So what he could see is not even close to what we can see now. This is the gravity of why the Hubble telescope really mattered. It's the gravity of why the James Webb is, it already matters, and it's about to be sent out to play. Is a more poetic way to put that, but I'm tired and the light's fading. Let me organize my thoughts. Yeah, so I think about this, honey. Ready? This is why I'm like trying to convince humans are like, you should. We are living in a fortunate time where we are seeing things that some of the greatest minds in our past wanted to see, but they couldn't. They didn't have the science and the tech yet to get out there. Or they're being held back by things like the church, which are threatening them with death and torture because they want to say the truth. Geocentrism was not the truth. Heliocentrism was. We're not the center of the galaxy universe. We're not even the center of our solar system. The sun doesn't revolve around us. We revolve around the sun, and we revolve around our axis. That's, again, we'll go into stuff later about how progress is being slowed down by idiots and by average people. Heater went off. I'm gonna grab some water. Light's fading. Maybe I'll continue the rest tomorrow, but I'll try to do as much as I can today. This is getting fun. I'm kind of getting into a rhythm. I love you already. Of course I did. I love you. Bye. It's getting dark here, but what? Where are we? James Webb Telescope. Yeah, I think the idea for this was started in. I should tell you why I'm really excited for it. It's ever since I first heard about it, like several years ago, I had said, and I knew what it was going to see or what it had the potential to see. I keep reading different numbers here. Some say that it's 20 times more powerful than the Hubble, and some say that it's 100 times more powerful than the Hubble. I just know that the Hubble changed my life for the better, and I owe a lot of happiness to it. So if that's what the Hubble did for me, man, I can't wait to see what the James Webb sees. So I'd always kind of had the dark joke that I just need to live long enough to see what the James Webb sees. It launches in 2 days, so give me another year after that. But then also you have to be born, so I'll stick around for you. I'll try. Okay, the James Webb, the mirrors on board are made of an element called beryllium. Beryllium has an atomic number of 4, right? Hydrogen, helium, lithium, beryllium. Boron, oxygen, nitrogen. No. This is carbon, nitrogen, oxygen, fluorine, neon. I think those are the top 10. So it has an atomic number 4, it's a number of electrons, an atomic mass of 9 for beryllium. 9 being 4 protons in the nucleus and 5 neutrons. So that makes up 9. Okay? It's light. It does well under cold temperature, which is key for this telescope. It's hard to find. I forget what percentage of the Earth is made up of it, but it has to be mined. It was mined across several states in the U.S. and I think like 10 or 12 states in the U.S. And then they get it. And I'm not sure that it exists on its own. I think it's combined with other metals. And then they cover these mirrors in gold. And that gold is microscopically thick. I believe it's something like 48 grams for the entire 18 hexagons on the James Webb. So that's 50 grams, I believe, is $2,800 right now in 2021. When you're born, it might be a little bit more. We'll see where Bitcoin goes. But gold, why is gold so worth it? I'm not even sure if people who love gold know why. I don't give a shit about gold, but for some reason people love jewelry is this huge hole I have in my life where I don't even get on a basic level why it's interesting, but people love it, so I have a lot to learn, I guess. But gold, its chemical properties is that it's extraordinarily stable. It won't react with anything, so you could bury it, leave it in the ocean, underwater, you know, whatever, and it won't react. It's also malleable. It's also, I believe, born from supernovas because the amount of pressure that has to that's involved. It can only be born in supernovas, and those that star guts ended up on Earth. That's why it's so rare and so valuable. So there's about 48 grams or 50 grams of gold that cover it microscopically, and that's good because it reflects infrared light really well. And this is an infrared telescope. The main difference between this telescope and other telescopes is that this is trying to detect things in the infrared. And why that's important is because in the light spectrum, white light is made up of red, orange, yellow, green, blue, indigo, violet, red, orange, yellow, green, blue, indigo, violet. 7 colors. That's white light. But the shorter the wavelength, you get up to UV light, which is ultraviolet. Even higher is X-ray. This can be really damaging for your cells, for your body. And the highest is gamma. So gamma light is being blocked out now by the atmosphere that we denigrated earlier for Galileo's sake. And on the longer wavelengths, you get infrared. I think microwaves. I'm just going to fight through it. I can't keep pausing. Microwaves, then radio waves. That's even longer wavelength. And I'm literally talking about the wavelength. So radio waves, microwaves, infrared, white light, UV, X-ray, then gamma's like this. So your eyes can only see white light. You can't see infrared, you can't see UV, you can't see X-ray. So if you get X-rays done on your teeth or your body, you can't see that light, right? But it is, you can't see that wavelength. This is specializing in seeing infrared, because remember how I said Edwin Hubble mattered and that telescope was named after him? What he discovered was, at the time, they were trying to figure out whether the universe was static, whether it was condensing, getting smaller, infinite, expanding, what? And he discovered that not only was the universe was expanding, and the farther away you are, the quicker you're expanding. I'm accelerating away. And I believe Sagan said, as if we had committed some sort of cosmic blunder, like some kind of social blunder. Things keep coming away from me. By the way, honey, since this is the first video, I have a stutter. I have a pretty serious stutter that I have masked by speaking in a different way. But whenever I get serious about a subject, you'll see it act up. So just know that, I guess that means I'm being more honest if I stutter. But it's really frustrating. Anyway, what's next? Okay, so when things move farther away from us, they do what's called a redshift. And a redshift, there's something called the Doppler effect, which you'll learn about. Everyone talks about it in like the most basic science classes. But the best example to give you is if you hear an ambulance or like a fire truck going by. Why do you hear that getting higher pitch and then lower pitch? Why does it sound like that? What's the true sound of that siren? Is it or is it right? It's kind of interesting. So when that's moving towards you, the sound waves are being condensed, because not only is it being released from it, then it's being condensed from the movement of it. And then when it goes away from you, those wavelengths are being lengthened, so it sounds lower pitch. That's how sound works. Something higher pitch, you see this? Something higher pitch has a higher frequency, and lower pitch higher pitch has a shorter wavelength. I shouldn't say frequency. Frequency is the frequency with which a wavelength comes through in a certain amount of time. So wavelength is the actual length, and we'll study all that later. There are troughs and crests, and we'll talk about longitudinal waves, transverse waves, why sound doesn't go through space. So in space, if you scream, no one can hear it, but light can, by the way. Light doesn't require a medium. So space is basically a vacuum, and there's no medium there. As best we know, we'll talk about dark matter later, which is inappropriately named. But that's why in space you can see things. Otherwise, if light required a medium, you would go blind in space. You wouldn't see anything. But that's like one of the best things. You can see another astronaut, but you can't hear them scream. I don't know why they're always screaming, but okay. So James Webb is going to mainly be focusing on the infrared, which is at the lower end of the spectrum. And why they're doing that is because Edwin Hubble discovered that these stars and these galaxies were going away from us, right? And when a star or a galaxy is going away from us, what happens to the wavelength? It gets longer as it comes towards us. So what we're seeing there isn't the true image of what we're looking at. It has to be adjusted for its expanding wavelength as it moves away from us. It's like if somebody asked you how a siren sounded and you went, that's not the true sound of it, right? If that person then goes up to the siren and he hears, he goes, no, that doesn't sound like it at all. You have to now account for, well, the siren was going away from me. So what I may have heard might have been different than what you had heard. Why does this matter? Okay. Because any image that we're taking from space, my brother's calling it. Let's do a pause here. A mote of dust suspended in a sunbeam. See that? Let's also say again. I think it's a mote of dust, he said. J.J. Abrams loves these solar flares. I mean, these lens flares. It's like I'm watching Star Trek. Is that okay for light? Who the hell cares? Let's keep talking. Why did I stop talking? Oh, okay. Well, this better be good because I dropped my new phone and dropped my laptop and I caught my laptop. Oh, brother. How's that? I say I don't care, then I suddenly care and waste all this time. What are we talking about? Beryllium, redshifting, lengthening wavelengths. Okay, why does it matter? Because, okay, how, and this is really, poetic too when you kind of think about it, is how you see things looks this actually gets really poetic because it has to do with solipsism, which is my second word of the day for my second video ever, which is about the yeah, I was saying before the heater went off, seeing isn't always believing, right? Look at even the lighting here. Do I look older? Do I look angrier? I have my notes light here. Do I, you know, lighting's such a big deal. It changes so much, right? My beard got darker. So what I'm saying is, okay, I was talking about solipsism. Which is that your mind creates your reality. You know, and we'll talk about that later. But like, and it goes. This is how my mind works. Why I don't get anything done. Just because I'm up, like, you know, I'm up now, fighting the light. I kept saying that the lights, you know, that it's getting darker. What that means is that the Earth keeps turning. What that means is, in Japan, people might be starting to wake up now and go start their day. I think about North Korea a lot. There are people there who are basically living in the dark, literally, who don't know what what's going on in the rest of the world. But their solipsism thinks this is it. Maybe they've heard about something outside of that, of their world. Maybe they haven't. But just because you see what's in front of you doesn't mean that's everything going on around you. Just because you're doing well doesn't mean other people aren't suffering. And that's a big theme in this series. We'll talk about that more later as well. But let's get out of the meta and the poetic and into the literal here. Why we mentioned infrared. How do you take an image of space? The same image can be seen in different ways. Something like this has to be color corrected and adjusted on a computer. So they make it really artistic and really beautiful. I'm not sure if you go there, if you're going to see it like this. There's Daisy out there. If you're going to see it like this. And the same image, you can actually look up online the pillars of creation and see how it looks like under infrared and different under different wavelength detection. Because when you look at something like the pillars of creation, you'll see the pillar of dust, right? This cloud of dust. But if you look in the infrared, you can see the stars being born inside of that nursery, inside of that dust, that star nursery. That's what I'm saying here. Just like with an X-ray, you can see you can see your bones. But if I took a picture, I couldn't detect that. But if I take an X-ray, I can see the bone through the meat, right? That's the idea here. That's why we, like I have any part in this project, that's why we are trying to detect things in infrared. Okay? The issue with infrared is these spectrometers and camera systems, if it's trying to detect infrared, it has to be really cold, incredibly cold. Because if it warms up, it'll detect its own infrared, which is heat. Do you see what I'm saying? So you can't be looking for a flat. It's like looking at a small light with the sun behind it, right? Like you shouldn't be doing, like it needs to be dark to detect things. So that's where the James Webb is designed in a way where they have a heat shield on it. I'm like, I think you can notice like the fluctuations in my energy through this video, especially because it's a long one. Maybe that's why it's long. I should forgive myself. Let's get more energized. James Webb, I am excited. I'm talking to you, hon. This is what it's all about. The James Webb has a giant, let's go to the drawing board. The James Webb has a giant heat shield that protects it from the sun. Because if you, okay, a couple of things. I like how I'm skipping around. Okay, I'm going to start with this. It's very exciting. There's a lot to talk about here. And from now on, I'm going to try to have a transcript because it's so disorganized. The Hubble is about 350 miles above the Earth. So if this is the Earth, it's 350 miles above it, orbiting about around the Earth. That's about 540 kilometers, something like that. The James Webb is going to an area called the L2 region, the Lagrange 2 region. That is 1.5 million kilometers away from Earth. I think 970,000 miles-ish away from Earth. So we're talking about 350 miles to 1 million miles. It's going to be far away. It's not the first thing that we put in the L2 region. I should stop saying we. Well, that the human race, I should say we, that the human race, right? I'm not sure I qualify anywhere close to the men and women working on this, but whatever. The human race, we'll say that. Even though that feels uncomfortable too. has put in that region. It's called the L2 region. Let's draw the L2 region. So it's called the L2 region. That's short for the Lagrange 2 region. So any two massive bodies, or any two bodies, this is not to scale, obviously. This is the sun, Solus, our sun, our star. I realize I gotta get out of here. This is Earth, right? Any two regions, when you check them, they have these points, almost like cosmic parking lots, where the gravitational forces between the two bodies allows something to rest there in peace without being moved either way. It's in like gravitational equilibrium. Okay, so I believe it was Euler who discovered these three. This is L1. This is L2. I should draw that out more, but this is L3. This is not to scale, obviously, okay? Ugh. And I think it was Lagrange himself who discovered L3 is somewhere here. L4 is somewhere here. This should be like an equilateral triangle. It's like equilaterally distant. Okay? So most things like the Hubble are here in the L1 region. The L3 region is a good area. If you're an alien civilization, you should be hiding here because it's hard to detect you. And if you want to set up like a satellite colony, this seems to be a good area because you can easily transport things back and forth. And the L2 region is good for keeping something away from the sun for the most part, so that it can face this way. So, you know, light coming this way can be blocked out. But so this is the sun, the light from the sun, it's being blocked out by the Earth, see? So you can put something there. I should have drawn this a little bit more out because the moon is, you know, orbiting the Earth. So let's call this the moon, okay? So let's call the L2 region then here, like that. So the moon orbits the Earth. And by the way, even the Earth and the moon have an L2, L1, L3, L4, L5 region. So even between those two, okay? So every two massive bodies have these 5 Lagrange points. Lagrange points. They're cosmic parking lots. So it's good. You can keep it there. And it's being blocked out by the sun is being blocked out by the Earth for the most part. You do need some sun for the solar panels on board. But it's now really dark here. So it's basically nighttime here. This will be 1.5 million kilometers. Okay. Okay. Okay, yeah. So why that's critically important is because remember I said earlier that the Hubble had there was an astigmatism with it, where it was off by 1/50th. I keep saying 1/50th. I want to now check that again. I hate that I have now quoted this 4 times without double checking it. 1/50th the width of a human hair. The good thing is, while the late night hosts were making fun of us or making fun of NASA and all that stuff, we could send astronauts back up there to go fix that focal point issue. You can't do that with this. When they kept talking about these delays or these, these delays or these budgetary issues, it's like, well, we want to get it right because you can't go up there to go. There's no second shot at there's no fixing that. You can't send an astronaut up there to go fix it. I'm sure maybe you could send up some sort of robot or something, but how does it do something so complicated, you know? So you want to get it right. And so I think this was first conceived of in 96-ish. I think this telescope was, and it was set to launch several years ago. Then they kept delaying it year after year after year, and like the budget kept going up a little bit. We'll talk about economics later. They shouldn't have any concern about the budget. It's like, spend the money. If you can blow $4.4 trillion in all those lives on 2 wars that were scams, you can spend $10 billion to go see the beginning of time and light. We'll get to that later. I get very angry about that because people die. And secondarily, you waste money. So, but people are dying. And this is this is the best of us, you know. We're trying to show what the best of us is. Okay, it's in the L2 region. That's good because I need water. Yeah, that's good because it's like looking out at the night sky. You know, you look out at the night sky, you can't see Neptune, Pluto, Uranus right now. You can see Venus. You know, right now I'm saying you can see Venus, Jupiter, Saturn, Mars. Why is that? It's not that Pluto and Neptune and Uranus aren't out. It's that right now they're out in the daytime. So you're competing with the sun's light to see the stars. That's why you can't see them then. But at nighttime when the sun goes away, or when the earth turns, should be more scientific about this, right? When the earth turns, you can see the night sky. Okay, so it's that James Webb is there. It's a big bucket. It's an eye in the sky. It has to stay cold, and it stays cold. Oh, right, that's where we were. It stays cold with sun shields. So let's draw it like this. I think I have to get out of this for cinematic mode, right? There's a big sun shield around it like this. And it's actually 5 layered. 5 layered. So the sun will be here, beating down on it. But this is facing away, that way, towards the beginning of light that I can see, the first light. Okay. You know why I'm getting exhausted? Is because I'm fucking competing with this heater. Let's get back to it. We had mentioned keeping the instruments cool. You keep it cool. There are like 4 instruments on board, spectrometers and cameras on board to detect infrared light. The issue with infrared light is that if your equipment itself heats up, that is infrared, and so it's detecting its own noise. It's a way to keep noise down from the image. You know, that's what we're trying to get here. We had mentioned that we're bringing a telescope from what Galileo observed of Jupiter below the atmosphere to above the atmosphere. That's the Hubble. Now you've created gold-plated sensitive mirrors on board of the James Webb, and you sent it to the L2 region, the Lagrange 2 region, so that's even darker, and you're going to have detectors detect infrared. So if you notice, what we're doing here is you're trying to make the image more and more pure with less noise and distractions in it, and you want just a dark place to just collect light. That's the goal here, right? By the way, the weight of it, the James Webb is huge, about the size of a tennis field. I believe that's either the lens, the mirrors itself, or that including the heat shield. And the Hubble is is so much smaller, but it's 100 times more powerful, and it's about the same weight, if not just a little bit more, I believe, because the material used to make it is that much lighter. And I think the weight of each mirror of the 18, I believe there are 18 on board, is 20 kilograms. So it's about 48 or so pounds. What's 48? What's like 50 times 20? 5 times 2 is 50 times 20 is 5 times 2 is 10, 1,000 pounds. So half a ton for just the mirrors. Someone out there watching me, so if I'm acting weird, that's why. Okay, but the cold side has to stay cold. The cold side stays about 270 minus 270 minus 233 degrees Celsius. That is 40 degrees Kelvin. Keep in mind that 0 Kelvin is absolute zero, which I think is impossible to get, right? It's when enthalpy and entropy meet. I forget the science behind that, but it's keeping this at, and the equation to move Kelvin from Celsius is just 1 to 1. So whatever the Celsius is, minus 273.15, I think. So if it's 100 degrees Celsius, it is 173.15 Kelvin, I think. Yeah, Kelvin minus 273.15 is the Celsius, equals C. So C plus 273.15. Sorry, it's at 373.15 degrees Kelvin. There you go. You don't, Albert Einstein was asked, I'm not comparing myself to Albert Einstein, I'm just trying to express something on how to think, and we'll do episodes on how to think or how I believe people should think. You don't need to memorize trivia or data. A lot of people, in a future video, I'll ask you what you think intelligence is, and then I'll give you my definition of it. I don't think it's trivia. Like, a lot of people get fooled by that, or they're called smart with that. I like trivia, and then people go, oh man, you're smart. That's not what I believe smart is, that you know random facts. It's how to extrapolate and how to get to something using basic tools. So you don't need to know what the speed of sound is. You just have to know what its properties are and what it roughly is based on other things, compared to other things. In the same way, you don't have to memorize the equation of Fahrenheit to Celsius. You should just roughly know how to get there. By the way, the equation for Fahrenheit to Celsius involves the number 9/5 plus or minus 32. I forget which one. Here's how we do it. I have memorized that at sea level, 100 degrees Celsius is equal to 212 degrees Fahrenheit. Maybe that's my trivia, right? So the Fahrenheit's larger, Celsius is smaller. Actually, you don't have to memorize. You just have to know that it's larger. So you take some number, multiply by 9/5, because that's going to be larger. 9 divided by 5 is 1.8, right? I think. It's going to be multiple. It'll get larger, plus 32. So let's do C times 1.8, or times 9/5. 100, so that's 180. Yeah. Plus 32. 212. See? F equals 9/5 C plus 32. I came up with it because we went through the steps. No, because I haven't memorized. Okay, but the onboard sensors, so for the most part, that is going to be operating, I think, in 40 degrees Kelvin. That's minus 233 degrees Celsius. And then the one onboard computer, which is called Mary, needs to operate at minus 266, I believe, degrees Celsius, which is just, what, 7 degrees Kelvin? That's so close to absolute zero, you know? And to do that, there's a cooling system inside, just like a radiator. Okay? Let's talk about engineering, by the way. Anytime you see something that's this great, where you're like, I can't believe this is happening, I mean, it's not made by a quantum computer. It's made by a human, and you're a human. So these things can be done, and you can do it. Don't let anyone tell you you can't. Don't, especially not with these Neanderthalic arguments that people are coming up with now. In like this day and age, people have ruined discourse. It's just being run by the average people, by the idiots. And you're not average. I'm not average. It's being run by the idiots. So they're talking about things like a woman can't do this, a guy can do this, or because she's black and he's white and he's Chinese. It's like, tell them respectfully, fuck off. You have a mind, you have a 3-pound brain. It's still the most complicated thing we've ever found in the whole cosmos. Use it. And you have like the time to do it. So it's a complicated thing, but things are, how engineering works is you have a goal. I want to see infrared light from the most faint, distant stars and galaxies from the beginning of time. How do I see that? Okay, where do I put it? What do I do? What happened with the Hubble? And you learn from there. Why I mentioned that is because with the Mary thing, when you need to cool something down, they use a radiator system, just like a car, just like a fridge. It's the same technology. Just tweaked to go up there, and you have the room and the time and the money, especially in this country, to screw up into, and you can bring in other engineers, and it's not all done by one person in their garage. It's done by a team. This is like the best part of engineering. And later in life, this is like a big lesson that I'll speak about later as well. I learned from some friends in Hollywood. It's like how movies are made and things like that. It's like you see the finished product and you go, wow, they made a movie. But it's like done piece by piece. And you can minimize your risk in a lot of ways too by testing it and all that stuff. So that's what they did with this too. They exposed it to extreme sound, just like the rocket ship. It's going to go off on an Ariane 5 by the ESA, by the European Space Agency, out of French Guyana. I'm going to keep going, okay? And so it's going to shake and experience sound. What do? Well, we got to make sure it doesn't shake. What happens when it experiences sounds from a rocket ship? I mean, how the hell do you get this into the L2 region, right? Then things like how do we get the focal point? How do we make sure? So you ask for more time, more money, and you just make sure that you get it right. You know how they went to the moon? That was based on how Columbus came, or how basically anyone comes to like a new world. When you go on the Nina, Pinta, and the Santa Maria, I'm a sailor. I'll show you how to sail, by the way, in a future video. I'm a sailor. I've been sailing now on and off for about a decade. You don't bring your boat up to shore every time. You leave it somewhere anchored, and then you take out a dinghy or a tender, sorry, my stutter's acting up, or a tender vessel, a, a tender ship. Last summer, I worked on sailboats off of Martha's Vineyard and Rhode Island, off of Rhode Island, but we went to Martha's Vineyard. And you have a transport vehicle that brings you to the larger ship. In the same way, to go to the moon, you have a giant Saturn V rocket that just gets you the hell into orbit. From there, you need to get out of orbit, slingshot. Now, who cares? Because you're in a vacuum. Then you need to slingshot into the moon's orbit, land, get out of there. But what? And then all that comes back is a small triangularly shaped thing with 3 people inside who are hopefully alive. The same way they talk about, okay, the Nina Pinta Santa Maria. How do we get from the shores of Europe to the New World? Well, get on a horse out of your house and get to the shore. Get on a rowboat that brings you up to the Santa Maria. Then the Santa Maria goes downwind or whatever to 1492. I don't think upwind sailing was discovered yet. The golden age of sailing, I don't think. I'll have to double check that. Maybe, I don't think it was. Was it? Maybe it was. I got to double check that. I'm surprised I don't know that. Then you get to the shores of the Americas, and you don't smash your Santa Maria onto the shores of the West India or Jamestown or Massachusetts. You take a smaller boat. In the same way, this is how they design. So you can find things in life that are designed a certain way and see if you can emulate it for something else. Okay, I'm getting distracted here by too many things. We talked about the radiator inside the mirror, right behind the mirror, to keep that cold, so it doesn't get noisy images. There are like 4 sensors on board and cameras on board. Near Cam, Near SSI, and Miri, and something else. Near, I forget, but we can go through all that later. It's just supposed to detect different wavelengths, and it'll kind of also block things out. If you see an image, you want to block it out so you can see the images around it. You can see what's around it. Let's see if we can even do that with this light. Anyway, it's like kind of like when you're looking at the sun, you can block the sun out and hopefully see something around it. That's the idea there. Why it's hexagonal shape? Hexagonal shape is because overall it's somewhat circular. Then it can be, it's 6-way symmetrical. So there are different optical prescriptions among the hexagons. So they can be moved in series to move the image and bring it into focus. So each one has an actuator behind it, I believe, and it can move it to within 1/10,000th of the width of a human hair. That's how exact and how precise it can happen. It can move. Also, there are rotational devices on the bottom of the James Webb, and I believe it's behind it on this side. And what that's there for is like when the James Webb is experiencing solar flares and radiation, it can move. So the issue is then you need a wheel to rotate the other way to help move it back into position. That's called angular momentum, by the way. You'll see it on a gyroscope. I can show you that. Or if you just take like a bicycle wheel and spin it and off a hanging thread, you can see what angular momentum does. And so that's there. That has to be propelled by something, and that I believe is what sets up the time limit. The James Webb will only last about a decade. That's what, they always say how long they believe it'll last, and some of these satellites and projects end up lasting a lot longer, which is nice. But based on that, it's supposed to last about 11 years, I think, like 10 or 11 years. By the way, why it's named after James Webb? James Webb was the second administrator ever for NASA, the National Aeronautics and Space Administration. So at the time, it was a fledgling branch. Rocket propulsion had been designed in Worcester, although it was kind of known about in Chinese cultures. They invented gunpowder. And he was the one from, I believe, like 61 to 68, who, so I think before the Apollo 11 missions, but who put a lot of stuff into action for NASA as we know it today, to be just this awesome organization. At the time, we hadn't gone to the moon yet, so we didn't know what our full potential was. And while it was a political and military race between the USSR and the US, I believe James Webb was on board for being like, look, I want to do this if we can have actual products that'll like better the human race and space exploration. So it wasn't just like a political motivation for him. There's been some controversy around naming it James Webb. There's something called the Lavender Scare, which was, I think, trying to suss out, gays and lesbians in government or something under Hoover. I don't know the exact history of it. I haven't researched it that much, but there was some controversy about whether he was involved in that at all or gave his imprimatur to it. I believe someone resigned from NASA because they kept the name. We can discuss all that later. That is very important, and what this channel's about is seeing all sides of everything. So that's not something we're going to shy away from. But that's why it's called James Webb. What else do I got for you? It's going to go... Okay, let's talk about this. I have to go pee, actually. Let me go pee and come back. I forgot what the last thing we talked about was before I went to pee. By the way, with me talking about the rotational wheels that are there to prevent angular momentum, or to dissipate it from the solar radiation hitting the James Webb telescope, hitting the heat shields, like the heat shields. That science behind the solar energy moving the heat shields, which is like essentially a sail. It's like there's actually a project called Starshot that tries to argue to send a computer chip. Essentially, it's very light and very small, with a giant solar sail around it. And you shoot the solar sail with a laser beam or with a source of energy from Earth, and you can get that to within 1/4 the speed of light. So the speed of light is what? 300,000 kilometers per second, I think. 186,000 miles per second, I think. Yeah, I think so. By the way, the moon is about 245,000 miles away from the Earth. It's a good fact to know. So you get a reference of where the Earth is, 245,000 miles, and then the L2 region is 1.5 million kilometers and 1 million miles away. By the way, also James Webb is not going to be in the L2 region specifically. It's going to be orbiting the L2 region. So it'll get some sun to power up its solar panels, which are on the underside of it. But that Starshot project, if it goes 1/4 the speed of light, the closest star I believe we found is 20 light years, or is 4 light years away, 4 or 5 light years away. So multiply that by 4, you get about 20 years. In 20 years, they should be able to send this computer chip that should go to that next star and see what it's like over there. So almost within one lifetime, you can go get information, have it sent back. That's called Starshot. So the science that we hate, we want to prevent the solar radiation from moving the James Webb, but in other projects we might want to use it. That's the idea there. What else I got for you? So much more to talk about. I'm so disorganized with this thing. It's the first video ever. I'm just going to kind of put it out there, kind of get things started, and it's a fun project. Usually these things have visuals and 2D representation and all that, but whatever. Talked about the actuators moving each mirror to within 1/10,000th the width of a human hair, so that can move each hexagon. And the optical prescription is that there's A, B, and C, so different mirrors work together to move the optic. And why it's hexagonal shape is so that the gaps in between is almost zero. And it's made by humans again. Okay, talked about the beryllium. Talked about why it's named, what it's going to look for. It gets focused by looking at a star and getting the focus on that star. It's the same thing I do with, I'll show you some of my time lapse. You put it into, infinite zoom, and you get the star as small as possible. Then you can go back, and that'll be the sharpest image that I can get on my camera. Oh, people are excited by what it can detect there. I mean, always the most exciting thing to write in an article for these non-scientists. They get excited about alien life and all that stuff, but I'm not so sure about any of that just yet. But what I can talk about is what it's going to detect in terms of exoplanets and stars, and how. So science, why science is really cool, is because it's a mystery, and you are Sherlock Holmes. You are trying to solve the case, and not explicitly by just coming upon the evidence, but you can extract what the evidence should be based on theories and hypotheses, right? So why I say that is Isaac Newton discovered that white light can be broken up into 7 colors. Yeah, 7 colors, I believe, through a prism. And if you use any sort of element lamp, like a mercury lamp, which is a light fueled with mercury, when that's put on a photosensitive detector, it will only, the frequency of that light, the frequency of that chemical is represented through light. So mercury only gives out a certain color. Do you see what I'm saying here? Each element will give out a certain color, and you can detect that color. If you detect that color, you'll know what that thing is made up of. So in this case, we're looking at stars, and you can tell what stars are made up of if you see certain colors. That should be what the chemical composition of it is. Now, there's a beautiful. Have you ever heard of the gloaming? The gloaming or the terminator, or basically dusk. It's that light right on the edge of when you have sun and when you don't. And you can see that outside is very nice. It's very dark out, you can tell right here. Okay, so when you have an element and it gets excited, it'll let out a certain light. That's how fireworks work. That's why fireworks are red or golden color or green or whatever. It's because they have a little bit of that element in there. So when it gets excited, it turns that color. That's how you can tell what elements are in a certain star or whatever. I'm getting tired, sorry, buddy. But it's been like 2 hours of this talking now. So, and that happens because an electron is being moved to a different shell. Basically, we'll talk about that later. This is how they discovered that light moves in packets like photons, and we'll talk about the double slit experiment, which shows that it can also act as a wave. It's why polarized glasses work, but you can't see. If you take a polarized glasses and you go like that, you won't be able to see. And why a solar panel works, because it shoots off an electron once it gets hit with a packet, a photon. And why photons, I think because they have no mass, they can't tell time. So it'll be the end of consciousness. The end of thought itself in the universe. Anyway, so let's think about the TRAPPIST-1 solar system. I shouldn't call it solar system because solar is named after Sol, which is our sun, Solus, sun. The TRAPPIST-1 system, how do you know there's a planet going around it? I think it's the Kepler that detects exoplanets just by looking at 1 square inch of the sky, and they found like 5,000 exoplanets or something. You look at a star, and you can find dips in its luminosity, in its luminescence, whatever the noun form of it is. You can see it on a graph as it dips. That means something must be passing in front of it, just like this, just like the light from my face, right? It gets darker. This is a stupid example I'm showing. It gets darker as something goes in front of it, or because something is blocking the luminescence from that star. You can tell then based if it's in the habitable zone as well. The habitable zone should be a zone around that star where life can inhabit it. So life, it's almost impossible for life to exist on Mercury, for example, or on Uranus, but it can't exist in Earth. You know, we happen to be in the habitable zone. Not we happen to be, we are in the habitable zone. That's how life is here. So how do you detect what the chemical makeup of the atmosphere of an exoplanet is? It's because when white light, which Newton says is broken up into 7 colors based on his work in 1666. By the way, guess how old he was then? 24. And there's also the plague going on there for 2 years, just like now. There's coronavirus, so we'll talk about that in a later episode too. How this should be a time for your Annus Mirabilis, the people of the world, but instead, I don't know what people are doing at the time. As that light goes through the atmosphere, certain wavelengths of that light will be absorbed by the atmosphere. And it can only be absorbed by that atmosphere if certain things are in that atmosphere, like carbon dioxide, methane, water. So if you see white light going through a planet, like just around a planet, and the detection of what came off that planet is now missing certain wavelengths, that must be because that atmosphere is made up of this, this, and that. So see how you're a sleuth, see how you're an investigator, you're a private eye, you're a detective, you're a scientific detective. That's all science is. It's a mystery, and you're trying to solve it based on clues, based on evidence. And even though we're limited by how far you can travel on your own two legs in a car, in a plane, a rocket ship. You're maybe 100 kilograms or 50 kilograms, or what. You're human. You're a bag of meat and with an endoskeleton and a 3-pound brain. That's what we're limited by. With our imagination and our understanding of the laws of physics, which I'll call the master science, but people will probably disagree with me. Look at how limited we are. Maybe you're 5'4", 125 pounds, 27 years old. I don't know. Maybe you're male, female, black, white, Chinese, tall, short, skinny, fat. I don't care what you are. I don't care. We're limited by certain numbers of things. If I ask you to go jump to the moon, you can't do it. If I hold your breath for 4 minutes, you probably will die. We're limited by certain things. But using science, technology, physics, we can discover more than what our body limits us to. In a way, that's not actually what our body limits us to, because we're using our brains to leverage our physical abilities and go find out what's happening millions of light years away, right? So if we detect what the atmosphere is of a far off planet light years away in a habitable zone of that star, and we go, oh wow, it's made up of a little bit of carbon dioxide, but there's a lot of oxygen there. There's a lot of water, we notice too, and it's in a habitable zone. What makes you think they're not doing the same thing about us? Right? This is the cool part of it. This is like the coolest part of it. After all this work, you detected, hey, we found a planet in a habitable zone that could support life, and they have water, they have oxygen. Well, we're a planet in a habitable zone, and we have water and we have oxygen. Maybe they found there's a little bit more carbon dioxide in ours because we're not taking care of our atmosphere, but we'll get back to it. We're trying. Who's to say right now there isn't a James Webb out there already on another planet, orbiting their L2 region, trying to discover us? Maybe they're focused on us. Maybe there's someone there making a video just like this, stuttering and stammering his way through it and changing the light and arguing with the heater. Maybe there's a girl there who hasn't been born yet, like you are. And there's a guy here who is excited to see her and hold her and to go share all this in real life. So that should give you some, perspective. I think, perspective is a big deal here. That's why the first episode, the first vocab word that I wanted to impart on you was myopic or myopia. It's about being nearsighted versus being farsighted, having a different vantage point than what you're limited to. Thinking about what others are going through, and not just humans. Think about what a rock is going through. Think about what a hydrogen atom is going through. Think about what somebody in North Korea is going through. Think about somebody who's a victim of murder is going through. That means somebody who's already dead. Are they seeing anything? Are they in heaven or hell? Are they unconscious, conscious? Are they waiting there looking at us and we don't even know it? Put yourself in a different perspective. And so this is a cool thing here, man. This is, girl. This is a cool thing. It's happening now. It'll be launched in 2 days. And I want to live long enough to see what it sees and long enough to see you. And these are just some videos that I'm making before that time is here. Okay? I love you, and I love you. But we're not done here. Let's go with a little bit more. I got a little more to say. Speaking of perspective, let's talk about this. In 1984, there's something called, I believe, the James Maxwell telescope. I believe it was assembled in somewhere in Europe. I want to say Edinburgh, but I don't think it's Edinburgh. And it had to be shipped to, I believe, Hawaii, okay? And I think it's NASA. It's been a long time since I read this, but I think it's NASA had hired a commercial ship to go send some of these huge steel parts that it had made to Hawaii from Europe. That fell through at the last minute, so they hired this private sailor. And he said, okay, yeah, I got it. And he loaded up his boat with all of NASA's really sensitive and expensive scientific gear. At the time, it's 1984. People are not tracking with GPS and satellite and all that stuff just yet for private people like us. But they found out later that he's extremely late. Apparently, he went to Portugal or something and grabbed some explosives. Then he sailed to Ecuador and dropped off the explosives. And they couldn't ever find where he is. And they found his, chart plotter. And he had just gone everywhere with all of NASA's gear. that he's supposed to be sailing directly to Hawaii. Finally, he goes through the Panama Canal. So he sells the explosives with this NASA gear on board. He has explosives on his boat. Goes through the Panama Canal. Finally, weeks and weeks later, he ends up in Hawaii, and he's offshore. Goes, yo, I got all your gear here. And NASA's like, you're several weeks late, and the penalty for you being late now outweighs your payment for doing this for us. Then he said, if you don't pay me, I'm going to dump all this stuff overboard. So this is how petty humans can get sometimes. Like, while the whole time we're talking about the magic of space and all this stuff and seeing the beginning of time and all that. The pettiness here is also, there's a guy going, oh my God, petty. We'll talk in a second. Yeah, the pettiness here. Okay, so he's threatening to go dump all this stuff off into the ocean. NASA's freaking out. Then NASA sent the Coast Guard. And they said I think the James Maxwell team got a court order saying that he was committing piracy on the high seas, because he had stayed out of Hawaiian waters and into like international territory in the water, and he was threatening to go dump all this overboard. 1984, a bunch of NASA gear from Europe to Hawaii that stopped in Holland first, by the way, not Portugal, Holland, to pick up explosives, sell them in Ecuador, go to the Panama Canal, showed up 10 weeks later. I got drunk. I'm a sailor. These people can sometimes be, drunken. It takes a weird type to want to do that sort of task. So, why am I saying all this? I just lost energy again. This is what keeps happening. The Coast Guard came and they nailed that order to the mast of his ship, which is, I think, custom at the time, or maybe even now too. They arrested him, and they got the gear to NASA. Why do I mention this? It's because how they built the James Webb's telescope with all this information you got here, this isn't even much information. There's so much more that goes into it, obviously, like the specifics behind everything. From concept to testing to assembling everything and all that stuff. It goes from, I think, the Goddard Space Center, which I believe is in Maryland. Some of it got assembled in Houston, I believe. Then they sent it to Northrop Grumman, which is in Redondo Beach, California, SoCal, and they do more testing there. Then you fold it up and all that stuff. Now the issue is, I'm talking about the best among us, right? The issue is they need to launch it. They're not going to launch it from Redondo Beach. They're going to launch it from French Guiana. It's along the equator, and even the equatorial forces, because the speed along the equator is really fast. It's like 1,600 kilometers an hour, I think. Yeah, I think that's the speed. So even you could use that equatorial force to help you with the launch. How do you get it from Redondo Beach to French Guiana? This is the beauty of engineering. You have this magical thing that took over 2 decades, I think, $10 billion. How the hell do we get to the launch pad here's the issue. There's a lot of piracy around there. There's a sailing channel that I follow where they kind of went through like the piracy along in Panama and the Gulf of Mexico and all that stuff. So what they did is they sent out a false date when they're going to send it. I think they also sent out a false ship. So people thought it's going to be on this date on this ship. It's not even close. They sent it in secret on a date that they did not announce, on an unmarked vessel. It has to go through the Panama Canal, which is carved by under Teddy Roosevelt's administration. We'll talk about that later. Goes through the Panama Canal, ends up in French Guiana on a boat. And it's now there, waiting. It's about 2 days away from launch. And then after it got there safely, they go, by the way, the ship's already here. The James Webb's already here. So that's to prevent piracy. We're going to talk about, I'm getting really tired, sorry. We're going to talk about economics a lot through this YouTube channel. So when we talk about piracy, and it's easy to laugh at them and make fun and be like, oh my God, whatever, because they're going not just for the equipment. They're not just going for they're going for the gold, which I said was about 48 to 50 grams. Which is only $2,800. I can give you $2,800. Not that it's like a small amount of money, but it's a small amount of money relative to what we're talking about here, right? But they also are just trying to hold this hostage so that they can get some, they can hold it for ransom. Sorry, I can feel my energy going down. Sorry about that, hon. We're going to talk about the economics of this stuff. It's easy to laugh and say, I am the captain now and all that. That's from a movie called Captain Phillips. But what leads a person to go into high seas piracy? What is the economics of that? What happened in their home country where they're not being, like, where this is a necessity for them, or the best method to make a buck? So that's what we'll talk about later. You can laugh about it, sure. Then, but I also want to get you involved in like the economics of it, because that is a human, as a human being, there. So anyway, I think that's really interesting. The juxtaposition of the greatest scientist trying to see the most faint infrared light at the beginning of the universe, and then this could all be hijacked by some guy being like, yeah, actually I'm gonna go, take that now, and you gotta pay me off for it. Okay, I think this should be my last section I do, because I can't think of anything else. There's a lot more to learn about this, all the details. I'm no expert in any of this stuff, just an amateur, and a huge, space is my favorite thing. So just wanted to share some of the things I'm excited about, and why I'm excited about it. Been waiting several years for this, and I've always joked, I have a bunch of emails out there probably saying, I just need to live long enough to see this. I had sent to my friends, and it's happening in 2 days. So we'll see what it sees. Yeah, along the lines of economics, the cost of it is only 10 billion. I'm getting sick of people saying, oh my God, it's $10 billion. It's like, I'm from Boston, and they had this project. So here I won't say we, I'll just say they, because it's failure, and JFK says success has 1,000 fathers, failure is an orphan. But they had a project called the Big Dig, which is supposed to take 2 years, $2 billion, I believe. And if you leave anything in charge of the federal government, it became $20 billion in 20 years, and a death of a minority woman who was going to Logan Airport, I think, to go pick somebody up, and the epoxy, or the cement, which they made it aggregate over here, fell on her and crushed her. Think about cost. Think about relative cost. 2 wars in the Middle East, solved nothing, lost both of them basically. One of them created ISIL, a power vacuum. One of them, Afghanistan, we're going to talk about a lot. I have a friend there, and we'll make a lot of episodes about Afghanistan. And that's $4.4 trillion altogether. Annual budget of almost $1 trillion for the military. Lost both. It's just, don't talk to me about cost. Don't talk to me about economics like I don't know. I know, and I'll teach you about it too. But if these people mention cost when it comes to space, tell them to respectfully fuck off. What else? I'm leaving on such a negative note. Yeah, people, get people excited about it. If somebody says, like, I'm not sure, and I've heard even scientists say, like, what's the point of any of this stuff? Or I've heard dumb people go, like, the things I learned in high school or college, I don't use in my daily life. I think that's on them. I use everything that I've learned in high school, college, and on my own. I think about it every day. I don't know what it makes life interesting. When you see things, you'll look at it, I was going to say differently, but you'll look at it truthfully, because you know how it works, and that's exciting, right? I guess I'll mention this here. At the end of this whole series, I do have a product that I want to present to the human race. It's to you, but this is more to the human race right now. Something that we can make, and it'll help bring our species out of its adolescence, which is what I maintain we're in, and to a more mature, into more maturity. So it has to do with the an understanding of cosmology and astronomy. So when people say, what is this for? What's the point of it? Whatever. And even people like, Christopher Nolan, they try to insert in Interstellar that some of the projects we used detected cancer, things like that. I understand that. I have a much larger product that can help more people. And I'm going to present that later. But let me get through the YouTube series and at least get a couple videos out that'll help to let you know me if you're following along, and kind of get where I'm coming from. By the way, more on etymology, and I'd mentioned the Starshot project, which is using solar sails to shoot with laser. Sailing, and I mentioned sailing a couple times. Do you know what astronaut means? And if you're from Russia, it's called a cosmonaut. A Russian astronaut is called a cosmonaut. And if you're from China, a Chinese astronaut is called a taikonaut. I believe that's how you pronounce it, taikonaut. So what does that mean? Astronaut, cosmonaut, taikonaut. So astro means space. Cosmo means all the cosmos, the universe. Taiko, I think, means space too. And naut is nautical. It means sailor. So space sailor. You're a space sailor. That's all it is. If you're an astronaut, you're a sailor of space. You're navigating in space. You're navigating the stars. And if you're a cosmonaut, you're a universe sailor. You're an explorer. You're out there sailing. Same in Chinese. So that's kind of cool, right? You're a sailor. You're a space sailor. I think that's all I got for you, hon. It's a long video. I'm tired. My voice is gone. So it's getting so dark out here. It's 5:10. It's dark out. Gonna go edit. Try to get this done tonight and out there. Be my first video. Don't think I have anything else to say. This will last about 10 years. I don't know when you'll be here. I'm in my head probably like 6 years. So it should still be active then, but you'll probably get like mature about it much later. So after it's all done, that's okay. There'll be other projects then. The Voyager 1 and 2 are still out there, and that was launched even before I was born. So it's kind of fun doing this. You get to see how things progress, right? Anyway, I miss you. I love you, and I love you. Bye.